quantities being multiplied. So you can do the product rule, or you can multiply it out and then do the derivative. I'm going to do the product rule, that way I keep that fresh in my mind. So we have our first derivative is 1. Our second, our derivative is 2x. Crisscross. 2x squared plus 14x. Crisscross. Plus, since it's product rule, x squared plus 8. Simplify, 3x squared plus 14x plus 8. That is our first derivative. Factor this bad boy, or quadratic formula. No square rooting. Bad, bad, bad. So you get 3x plus 2, I believe. And I did that by doing a tic-tac-toe board, and x plus 4. If you have questions about the tic-tac-toe board, ask in class. I'll be sure to help. So for this one, you subtract the 2 and divide by 3, so you get negative 2/3 for x. For this one, you subtract 4. To find your y value, do you plug into the original or to the first derivative? Original, you should say. So we plug in negative 2/3 to our original, and you get crazy 53 and 13 over 27. 53 and 13 over 27. You plug in negative 4, and you get 72. And that both of those went into the original to find the y value. So we have to do a chart again, and this time our chart has 5 little boxes because we have 2 critical numbers. Negative 4 comes before negative 2/3. Negative 5 comes before negative 4. Negative 1 is between those two. And 0 comes after negative 2/3. So, if you plug in negative 5 to the derivative, you get 13. If you plug in negative 4 to the derivative, you get 0. If you plug in negative 1 to the derivative, you get negative 3. If you plug in negative 2/3 to the derivative, you get 0. You plug in 0 to the derivative, you get 8. So, 13 is a positive number. That's a positive slope. So our graph is increasing. Negative 3 is a negative number. So our slope is negative and our graph is decreasing. Here, our slope is a positive 8, so we're increasing. Make your intervals. Negative infinity to negative 4. Negative 4 to negative 2/3. Negative 2/3 to infinity. So this time, our graph increased, decreased, increased. So this is our first critical number at negative 4, and it looks like it's a mountain. So that is our relative max. Here, our second critical number is negative 2/3, and it's in our valley, and that is a relative min. And some of you are like, why do you have to do this over here to be able to tell if it's a relative min or max? You don't if you have 2 critical numbers or more. But what if you only have 1 critical number, like our first example? We couldn't tell if it was a max or min until we did that. So it's just a way to check. You can also look at the y values. Whichever one's higher, that's your max. So it's a way to just double check yourself. And it also gives us our intervals there for us. Alright, the last example of the day is one with a quotient rule. So we have our low, derivative of the low. We have our high, derivative of the high. Crisscross, and you get 2t cubed minus 32t. Crisscross minus 2t cubed, since it was quotient, you subtract. So on top, you just get negative 32t over the bottom squared. So we set that equal to 0, because we're trying to find our critical number. When you have a fraction and you have the denominator has a variable, you multiply by the denominator. This still happens to make our denominator go away because you're multiplying it by 0. So you get 0 equals negative 32t. So what is t? T is 0 if you saw. you plug back into the original, and you get y equals 0. So your critical number is 0, 0. However, this was a fraction, so we have to remember with critical numbers, also have to state where we undefined. We are undefined when our denominator is 0. What makes the denominator 0? 4 and -4. So we're undefined there. That means something crazy is going on in our graph. Probably a hole or an asymptote. We'll find out soon enough. Anyhow, we have 3 critical numbers we have to do in our thing. So if we have 3 critical numbers, that means we're going to have 7 boxes, not 5. Okay. So -4 comes first, 0 is in the middle, and 4 is on the end. A number before -4 is -5. A number between is -1. Between is 1, and after is 5. Plug those into your derivative. And when you plug in -5 to your derivative, you get 1.97. 1.98, sorry, I rounded wrong. When you plug in -4 to your derivative, you get 0. When you plug in -1 to your derivative, you get 0.14. When you plug in 0, you get 0. Hey, wait, -4, you don't get 0, you get undefined. Sorry. When you plug in 1, you get -0.14. When you plug in 4, undefined. When you plug in 5, 1.98. And those all were being plugged into the derivative. So here it's positive, so we're increasing from -infinity to -4. Here we are increasing again from -4 to 0. We decide to decrease, because it's negative, from 0 to 4. And then we decrease on our end as well. Oh man. So if we're decreasing on the end as well, that's going from 4 to infinity. Since we're decreasing as well, that means we cannot put that together because at 4 something is going on. So some of you are probably going to try and write that together, but you need to keep it separate because you can't say it's decreasing at 4 because something is going on with the graph. Alright, so if you're increasing at first, we're increasing. I'm going to leave a gap here because at -4 it was undefined, so you aren't going to have a point. Then we're increasing again, and then we decrease. Then I'm going to leave a gap at 4, and we decrease again. So your graph is kind of jacked up on this one. So what that tells you, at a critical number of 0, that was our middle one, that is a mountain, so that is a relative max. Please come with questions next time, and we can go over these examples. Great job.